last video, we took a look at what a geometric series was and also how we could determine if a geometric series converges or diverges. Now, in example 4 here, we're going to take a look at how we can put to use these ideas to actually find a very interesting and surprising fact. So consider the number here, 0.9, repeating, right? So that's that bar on top of the 9 means the 9s go on forever. Now this is kind of a strange decimal value, these repeating decimals that go on forever. But 0.9 is particularly interesting. I'm actually going to be able to see that I could express this value as a geometric series. And I can write it in sigma notation. To see how I would do this, first just note that if I have 0.9 repeating, I could at least start to write it as a super long addition problem, an infinite addition problem. Because I know that if I took something like 0.9, that would not be the same as 0.9 repeating. But if I added on like one extra 9 to it, like this, notice if I add these together, I get 0.99. And then I could add together 0.009, right? So that's 0.999. And I could just kind of keep going with this. And if I went on in this sort of a fashion forever, that's the same thing as 0.9 repeating. Now, what I can see is kind of interesting here is that this is a geometric series with our value of a being 0.9, right? Notice that is the first item in the list. And remember that the value of r is the value that I would multiply by in order to get from one value to the next. So what is it that I need to multiply by to change something like 0.9 to 0.09 or 0.09 to 0.009? Well, actually, yeah, I could just be multiplying by a 0.1. So I also have r here is a 0.1. So thus, I could see that 0.9 repeating is actually the same thing as the series where I say goes from 1 to infinity of 0.9 times 0.1 to the I minus 1. This is a geometric series. Okay, so that's kind of cool. But oh, wait, this would be important. If I have a geometric series, can't I find what that geometric series adds up to? Or if it adds up to anything, right? Because maybe it doesn't. If I look back at what we saw in the last video, I look back at the previous theorem, what I'll see is that the convergence or divergence of the series depends on the value of r. So I'm going to look at that value of r and try to determine if its absolute value is less than 1 or greater than 1. Let's see. Well, if my r value is 0.1, then I can say, since the absolute value of r is equal to the absolute value of 0.1, which is just 0.1, and that's clearly less than 1, then I know that this geometric series must converge. So that would mean that 0.9 repeating, which is equal to this infinite series, has to ultimately be equal to whatever this series converges to. But notice there was that formula that we had before. It had that shape of a over 1 minus r. So notice if I put in my value of a and 1 minus my r, I'll see that 0.9 repeating is going to pop out over here. So notice I'm going to get 0.9 over 1 minus 0.1, that's 0.9, and this is going to be the value 1. I need you to stare at what we just wrote there, because this is really important. I never abuse my equal signs. Look at what we just said are the same. 0.9 repeating and 1 are equal. They are the same number. They're not close. It's not like, well, if you round up the 0.9, then it happens to be a 1. No, no, no. Those are the same number. They're the same thing. 0.9 repeating is the number 1. It is the number 1. Here's the argument. In fact, this has a bunch of really hilarious consequences, if you will. Because if 1 is the same as 0.9 repeating, could you figure out what 2 is the same as? Well, yeah, that should be the same as 1.9 repeating. In fact, pretty much every number now you have multiple different representations for. Notice I could say I want 10.5. Well, that's the same as 10.49 repeating nines. This is great. In fact, these are fantastic things that I would highly encourage you to go ahead and utilize when you can in classes outside of math, just to screw with people. It's a great time. Like next time you're in some social sciences class, right? Or I don't know, maybe you're in like a physics class or something, and you get down to a final answer on a problem, you do a bunch of work. Instead of boxing the number 2 as your answer, why not just go ahead and write 1.9 repeating, right? Just to, when your instructor comes to you and say, "Well, sorry, you got that wrong," you go, what are you talking about? 1.9 repeating. That's exactly the same as 2. Don't you know about geometric series? Now, I have had some students that have done that in the past, and instructors have marked them off for it. And I always tell those students, and let the teacher know they can come talk to me. And for all the students that have done that, they have earned all of their points back. It's a pretty hilarious thing to do, but it's completely mathematically accurate. 0.9 repeating is the same as 1.